One of the best things about Android's Java language is that it's a managed memory environment. That is, you don't have to be super careful about handling when objects are created or destroyed. While this is generally great, there's some hidden performance problems lurking under the surface here.
Now remember, the memory heaps in Android's runtimes are segmented into spaces based on the type of allocation and how best the system can organize allocations for future GC events. And each space has its own reserved memory size. When the combined size of an object in a space begins to approach its upper limit, a garbage collection event is kicked off to free up space and remove unneeded objects. These GC events aren't generally a noticeable problem to your performance. However, a lot of them occurring over and over and over and over again can quickly eat up your frame time. The more time you're spending doing GCs, the less time you have to do other stuff like rendering or streaming audio.
One common situation that developers can fall into that cause a lot of these GCs to occur is known as memory leaks. Memory leaks are objects which the application is no longer using, but the garbage collector fails to recognize them as unused. The result is that they stay resident in your heap, taking up valuable space that's never freed up for other objects. As you continue to leak memory, the available space in your heap's generation continues to get smaller and smaller and smaller, which means that more GCs will be executed more often to try to free up space for normal program execution. Finding and fixing leaks is tricky business. Some leaks are really easy to create, like making circular references to objects which the program isn't using, while others are not so simple, like holding on to handles to class loader objects as they're being loaded. In either case, a smooth running, fast application needs to be aware and sensitive to memory leaks that may exist. I mean, your code's going to be running on a federation of devices and different types, and not all of them are going to have the same memory footprints and sizes. Thankfully, there's a simple tool that's available to help us see where these leaks might exist inside the Android SDK. Let's take a look.